right, here we go. So, simplified trigonometric identities. We back up here. We are going to do these slightly more difficult problems. So, um, you want to be able to have your sheet handy. So, Emma took this and tore it off. She's going to look at both sides of this today. You need to have this handy. When I reference a formula, I encourage you to look it up and make sure you know where we find it. Okay? Gotta know where we find it. So, I start with tangent squared over secant of theta minus 1. Can you identify what's different about this problem compared to the ones we did yesterday? Yes, very good. Slightly more difficult, the directions. Nice job. What else? So minus 1. I think I had a secant squared minus 1. Kind of looks like that, right? What's different? There's no squared. So some people would say, well, this is going to be tangent squared divided by secant squared minus 1 is tangent squared, so secant minus 1 would just be tangent. No way. That's Buddha math. That does not work at all. So, the question is, what do we do? And I'm going to do kind of a reverse substitution, so to speak. Instead of substituting in tangent squared or something, I'm going to substitute something in for tangent squared, namely 1 minus secant squared of theta. I'm sorry, secant squared of theta minus 1. Tangent squared is equal to secant squared minus 1. It's number 6 on your sheet. I also recognize that secant squared minus 1 is the difference of two squares. If you had x squared minus 9, that would factor to x minus 3 times x plus 3. So therefore, secant squared minus 1 factors to secant plus 1 times secant minus 1. What happens? Cross off secant minus 1, so we get secant of theta plus 1. That's all that. Question. I'll do this as quickly as I can. We've done it once before. X squared plus y squared is r squared, right? In the unit circle, x squared plus y squared is equal to 1, right? X is the same as, in the unit circle, cosine. Y is the same as sine. So you have sine squared of theta plus cosine squared of theta is equal to 1. Got that one. Now, divide through by cosine squared. You get tangent squared of theta plus 1 is equal to secant squared of theta. I can come up with all those from there. I mean, it's just, it all comes from the Pythagorean theorem, which we turn in the formula for a circle, which we turn into the unit circle, which we turn into sine squared plus cosine squared. It's the unit circle brought to life. Yep, the circle of life. There you go. All right, here we go. Every single one of the formulas you see, I can derive them for you. We just simply do not have enough time. There's about 480 of them. So, we have cosine theta plus 1 over sine squared. What I'm going to do now is I'm going to take that cosine theta plus 1. I'm just going to leave it on top there because that's not anything that we know. But sine squared I could rewrite as 1 minus cosine squared. I chose to do that because I know 1 minus cosine squared factors. One minus cosine of theta times 1 plus cosine of theta. Is cosine of theta plus 1 and 1 plus cosine of theta, are those the same? Why? They're not in the same order. Okay, addition is, so let's see, commutative. Very good. We're going to cross those off. If you could spell that out later, because it's a new word I've never heard before. I would love it. I love this class. So, All right, what do you notice? What's different about C? It's already factored. There's no squared, right? Fact is, if we could create a squared, that's better off because most of our formulas have a squared in them, right? I could create a squared pretty easily. I'll just distribute. I get secant squared of theta. And what's secant times cosine? What's the relationship between secant and cosine? They're reciprocals. And when you take two reciprocals and multiply them together, you get uno. What is secant squared minus 1? Booyah. Again, I'll distribute sine. Sine times sine. Sine squared of theta. Sine times cosecant. What's the relationship between sine and cosecant? Reciprocal, so you get. So I just have 1 cosine squared. What's sine squared plus cosine squared? One. Isn't it formula number 5? Isn't that the most fundamental trigonometric identity that we learned? Didn't we learn that once before? If there's something you remember from this course, other than SOHCAHTOA, please remember that sine squared plus cosine squared is 1. Okay? And to give your mom a birthday present on your birthday. Exactly. Very good. She suffered. You did it. All right. I'm going to multiply this out again. 1 times 1. 1 times cosine. Negative cosine times 1. And negative cosine times cosine. What do you notice? Yes, because they are conjugates. Another word that starts with C. They are conjugates. You can tell the ending changes, so the middles will cancel. You're left with 1 minus cosine squared. That is 1 minus cosine squared. Sine squared. Your math nerdiness is starting to come out. You guys actually like this stuff. You find it quite interesting. You wish the lesson would last all through spring break. You're considering taking calculus next year. All right, next one. Conjugates again, so the middles will cancel. I get tangent squared of theta. What? Minus secant squared of theta. What is tangent squared minus secant squared? It is negative 1. If you would look at 1 plus tangent squared is equal to secant squared, you could move things around. If you simply subtract the secant squared and subtract the 1, you would get a negative 1, wouldn't you? I multiplied it all out. Tangent times tangent times negative secant. Just multiplied it all through. Hi there. I hope you have a really good spring break. You're busy? No. Busyness is tough. Oh boy. Ooh. Well, I hope that you're able to watch a movie or take a nap or something. All right. Well, you take care. All right, let's multiply this out. What do we get? Minus 4. Oh no, it has a 4. What should I do? Factor out the 4. So the answer will be 4 tangent squared of theta. Good. What's different about the next one? addition. Okay, what else? Okay, you got addition with multiplication. We also have no squareds available, do we? We're going to have to be a little bit more creative and come up with a squared here. If you take cosine times tangent, you come up with a squared. If you take cotangent times cosine, you come up with a squared. Yes, you do. How do I get a squared out of cotangent times cosine? Cotangent is cosine over sine, so you'll get a cosine squared. So our best option here is to actually change the color scheme. Our best option here is to rewrite. Oh, wait! All right. To change this to everything in terms of sine and cosine. What do you notice? Well, that's kind of nice. I got a cosine squared out of it. Can't really do anything with it. Thoughts? It's where the aha moment has to happen. Both are excellent ideas. Neither one will get you. Yes! Common denominators! What's the common denominator? And if I multiply top and bottom by sine, what will I end up with? A sine squared. So we get sine squared of theta plus cosine squared of theta all over sine of theta. What is sine squared plus cosine squared? 1! And 1 over sine is cosecant. Sweet! Which part did you say O to? Like that? Oh yeah. That's the best one of all. Letter I is going to fall very similar to that. Sine squared of theta over 1 times 1 over cosine of theta plus cosine of theta over 1. Again, I have a sine squared, but I don't have a cosine squared. If I multiply the top and bottom by cosine, that would give me cosine squared, wouldn't it? What does it look like now? They will all be over cosine, right? Because they have common denominators now. And sine squared plus cosine squared is 1 over cosine. Tricky secant. All right. What about the next one? Excellent. But it's not squared. And it's tied to sine and tangent. When in doubt, I just try to rewrite terms of sine and cosine if I can't substitute something. Maybe something will go away. Cosines go away. You're left with, which is awesome sauce. It's his birthday. He's supposed to be smart. All right, I gotta take off the jacket for the last two. It's warm enough in here. All right, here we go. Let's finish them off. 2 more problems. When you have two fractions, sometimes it's best to just try to combine them together and see what happens. If you look at this scenario right here, it's not very intuitive to think about what's going to cancel. Fortunately, that doesn't work. So I'm going to find common denominators. I'm going to find common denominators. The common denominator will be sine of x plus 1 times cosecant of x plus 1. And it looks really, really bad, doesn't it? So that's that right there. And that's that right there. So let's multiply. What's cosecant of x times 1? What's 1 times 1? Sine of x times 1? X. And 1 times 1? That's my top. Let's do the bottom. All I have to do is just multiply these two together, and that would be the denominator, correct? What's cosecant times sine? 1, because they're reciprocals, right? What's cosecant times 1? What's 1 times sine? And 1 times 1? Yeah, it's the same thing on top and bottom, isn't it? It's the exact same thing. Is that nice? I foiled them out. Cosecant times sine, cosecant times 1, 1 times sine, 1 times 1. 1, because they're reciprocals. All right, for our last problem, L. I do not have at this time a denominator, so I'm going to write it as sine of x over 1 plus cosine of x plus cosine of x over sine of x. Now I've got two denominators. Yep, so I'm going to take sine of x over 1 plus cosine of x and cosine of x over sine of x. I can multiply top and bottom of each to get a common denominator. So sine of x over sine of x. And 1 plus cosine of x over 1 plus cosine of x. Now, sometimes as you go about these problems, you should kind of glance ahead and say, is my method going to have any merit to it? Have any validity? So look at the left-hand side. What do you get? Question. Like right here? Because then you would have to go over to Miss Nelson's class and get your finger cut off. Exactly. All right, so in this situation, and if you ever have that question, like this is what I would literally do sometimes when I was doing this. Or, 3 over 1 plus 5 plus, and then it looks like I put a 5 in for cosine, so 5 over 3. And I would think about that. So that'll be 3 over 6, right? Well, so I would just try crossing off the 3s, see if it would give me the same value. It does not at all give me the same value. You know what I mean? So if you're wondering, you can always try to plug in values to say, okay, would that work if I did this? Now, if you change this to multiplication, it sure would give you the same value if you cross them off. So sometimes it's a way to kind of check to see if the property would work or not. Okay, so no, we cannot cross the signs off. So now what we're going to do is you're going to get what here? And what will you end up with here? Yeah. So I get a sine squared and a cosine squared. Is that a good deal? It is. So we get a sine squared plus cosine of x plus cosine squared of x. Remember, you got to multiply the cosine by all of that. Okay. So important to say that. Divided by, I'm going to write this in factored form. I'm not going to distribute it through. A lot of times your denominator, you want to leave in factored form to see if something cancels. You just write sine cosine. Sine squared plus cosine squared is? Yeah, these two make 1. So therefore we have 1 plus cosine of x over sine of x times 1 plus cosine of x. What happens? 1 over sine, which is cosine. I'd say that's the most challenging problem that you would probably see come test time. But I would say I do expect that you would be able to accomplish it. Because you're the best of the best. You're super smart. And you love mathematics. I can see it. I see it in your eyes. Oh, no, we don't have tests for a while. We will take some assessment, and as soon as you get back from break, I'll let you know exactly what the homework is. It'll be that Friday. There you go. There's your homework. So if you didn't start yesterday's assignment, you could just do 1 through 22. Because yesterday's problems were 1 through 22, but not the problems listed there. So together, yesterday's assignment, today's assignment, make 1 through 22. Okay. Good luck. Oh! I forgot to show you one last thing. Sorry. You can just look at it. You don't even need to write it down. There's one last thing I need to show you, okay? You are not allowed in trigonometry to leave a negative angle. If you have sine of a negative angle, it's equal to negative sine of that angle. Cosecant of a negative angle is equal to negative cosecant of that angle. But watch how it's different for cosine. Cosine of a negative angle is just cosine of that angle. The negative disappears. Same with secant. But for tangent, it's just like it is for sine. Tangent of a negative angle is equal to negative tangent of that angle. Cotangent negative angle equals negative cotangent of that angle. So if I write this really quick, see if you guys get this. You might see something like this. If I write this, help reduce this with me really quick. There's no negative angle there, right? So I have 2 tangent of theta. If you have cosine of a negative angle, it just goes away. Yep. Just for cosine and secant. You want me to show it to you? I'm going to show it to you later. What happens to the tangent? It moves out front. So you can see that what will happen then is these two will cancel. This expression is just cosine of positive theta. So if you see a negative angle, use those options. We have covered all of these formulas so far, and the ones I just showed you are these even and odd identities that we refer to. So please make sure that you pay attention to them and know where to find them. I'll bring it back to your assignment so you can write it down again. And